Hi everyone and welcome back. Today I wanted to go into a few examples of using Newton's laws and looking at some different scenarios in order to determine the overall force being applied to these different scenarios. Okay, so I took some examples from your book, your textbook, and I'm just going to go through them. Okay, so for this first one, we have a barge here, and we have two boats pushing on it with some force, as you can see here and here. Okay, a force in the X direction and a force in the Y direction. Okay, the problem also states that the mass of the barge is 5.0 times 10 to the 6 kilograms, with an acceleration to be observed of 7.5 times 10 to the negative 2 meters per second squared in the direction shown, and that is here. Okay. And we want to determine the drag force of the water on the barge that's resisting the motion. Okay, so that may have felt like a lot of information, but once we break it down, you'll see that it's not too bad. Okay. So our first step would be to draw our situation, which they have already, which is good, so that I don't have to kind of try to draw it for you and fail miserably. Okay, and then you want to start breaking down all of our components. Okay, so we know that we have some force in an X direction, F sub X. Actually, let me make this a little smaller. Erase that. All right, so we have some F sub X, force in the X direction, and we have some force in our Y direction. Okay, so this is like the tip to tail method. Okay, so we put one force and we're adding another force. And so our overall force that's being applied to the barge, not asking or not thinking about drag yet. Okay, so this is just the overall force that's being applied to our barge here. Okay, so this is what we have, and since I keep saying it's the force applied, I'm going to call this F sub app, as in force applied. Okay, so this is going to be our first step to understanding the problem. Okay, the next thing would be that it told us that the barge has some mass and an acceleration. So that acceleration is telling us that the barge is moving, okay, with some acceleration in this direction. Okay, and we can call that theta. Okay. So the barge is moving in some direction this way. Okay, so if it has some acceleration, that means that it has some force, right? So I'm going to call it something else. So again, this one is F applied. Okay, and then this one, if it's moving, I'm going to call it the net force of the system. Okay, so that is taking into consideration the drag from the water. Okay, this is how much force that is moving that barge. Okay, and then of course we do have that drag to take into consideration. So I'll call that F sub D. So my drag force by the water. Okay. So as you can see, my drawing here now looks similar to this one. Okay, so we've got our setup here, our free body diagram, which I'm going to call free body diagram. Okay, so that's what we have here or over there too. Okay, one thing that you can notice right away is they also have some angle here. And the way that they figured that out is because that's the angle of the acceleration here. You see that angle right there? Okay. that is going to be the same angle that's formed here. Okay. So our acceleration is in the same direction as our force, our net force. So acceleration in same, I'm going to just write that down, direction. Okay. Okay, so hopefully that made a little bit of sense. If not, I would suggest to pause the video and kind of think about it a little bit. Maybe try to recreate that on your own. Okay. Okay, so now that we have a free body diagram, now we can start breaking this down and figuring out or answer our question. So our question again, let's remind ourselves, what is the drag force of the water? Okay, so that means we're looking for this force here. Okay, our drag force. What is that equal to? Okay, so let's write down what we do know. Okay, so we have our F sub x, we have our F sub y, right? From those two, we can figure out our applied force, right? Because it's just those two added together, right? That's our applied force. Okay. We know the mass of the barge, and we know the acceleration of the barge. Okay, so with our mass and our acceleration of the barge, so with those two parameters, we can determine the total force, okay, overall for the barge that's being applied to the barge. So not just the applied force, but also the drag force, taking that into account, okay? Okay, so we can look at our diagram here, and from that diagram, come up with a way to calculate these different things. So our F applied, okay, remember our Pythagorean theorem, this is just a right triangle, okay. Our F applied squared is equal to the F sub x squared, so our x force plus our y force, okay, so our force in our y direction, okay. Or we can write it this way as well. It all comes back to our vectors, okay, solving for vectors and all of that good stuff. Okay, so now we have our F applied force. Okay, I haven't plugged in any numbers yet, but that is how we're going to calculate it. Okay, so our next step is going to be to figure out what our F net is. Okay, so our net force, like I said, is based on our mass and acceleration. Okay, Newton's second law, right? So F net equals the mass of the barge times the acceleration of the barge. Okay. So our mass is, what was it again? 5.0 times 10 to the 6th kilograms, and has an acceleration of 7.5 times 10 to the negative 2 meters per second squared. Okay, so use a calculator and we get, let's see, 3.75 times 10 to the 5th, whoops, newtons. Okay, so now I have my net force. I can go ahead and solve for my applied force as well. I'm going to move down here. Okay, so my F applied force is going to be the 2.7 times 10 to the 5th newtons squared plus 3.6 times 10 to the 5th newtons squared, all that under a square root. Plug that into your calculator and you get 4.5 times 10 to the 5th newtons. Okay, so now we have our net force. So our net force, again, is our overall force, and that's going to be involved, excuse me, including our drag force. Okay, and then we have our applied force, which is the applied force on the barge by these two little boats. Okay? Okay. So the final thing is to figure out the drag force. So when we're looking at our diagram here, okay, maybe I'll draw it again real quick. So again, we have some force in our x direction, force in the y direction, pretend that's a right angle, okay? And we have our applied force, which is those two added together. Okay, and then we have our net force. Whoops. Our net force. Whoops. Maybe 28th time is the charm. Okay, so we have our net force. And then our drag force that's going against our applied force. Okay. So if you look at this side here, you see that we have something in this direction, right? This applied force. And this length is going to be the same as this smaller length plus this length going in the opposite direction, okay? Or we can say our F applied force equals this here, this F net, okay, plus, and it's going to have to go the other way if we really want it to add up to this, our drag force, if that makes sense. Or I guess it would just be the magnitude. So we can just say that the magnitudes added together, right, equal the whole thing. Or we can also say this, and this is probably the easier way to think about it. I would say that our F net, or our overall force, is going to be that applied force minus our F sub D, okay? So our drag force. So again, applied force, whoops, minus our drag force. Okay, because think about it, our drag force is trying to push against that barge from being moved in one direction. Okay. All right. So with that, I can now solve for my drag force with that equation there. So my drag force is now going to be equal to F applied minus F net. And again, that makes sense if you look at this again. So this length is going to be equal to this whole length minus this smaller length. Okay, so it all comes back to just looking at the diagram and what makes sense. Okay, so now what I'll do is I will plug in my values. So my drag force is going to be my applied force, which is 4.5 times 10 to the 5th newtons, and subtract my net force, which is 3.75 times 10 to the 5th newtons. Okay. So plug that into your calculator and you get 7.5 times 10 to the 4th newtons So this is my drag force, okay, on that, or caused by that water, okay? So that is resisting the motion of the barge, okay? All right, so I'm gonna stop here and then I will go on to the next problem.